All right, more verifying identities. We have another identity here that looks absolutely complicated and not obvious at all. How in the world that big mess on the left-hand side might be equal to 2 times cosecant x, but we're just going to play along with it. So we always start with one side of the identity. Doesn't matter which, but I said that starting with the more complicated looking side is probably your best bet. So I'm going to start with the left-hand side because it definitely is the more complicated side. So I'm going to say my left-hand side. And I'm going to use that same trick that I used in the last one. Everything's already in terms of sine and cosine, but I can add those two fractions together. So I'm going to leave myself a little bit of room when I copy these. So 1 minus cosine x over sine x, and sine x over 1 minus cosine x. All right, so I'm going to find their common denominator and add these two fractions together. And I have no idea what's going to happen when I do that. We're just trying something. All right, so my denominator, my common denominator is just going to be the product of those two denominators. So sine times 1 minus cosine. So this first fraction needs a 1 minus cosine on top and bottom. All right, and then on the right, I'm going to need a sine. So give me a sine. All right, so it's probably going to be helpful to put the 1 minus cosines all in kind of brackets or parentheses. All right, we're going to have to be careful with this. All right, so let's see. Up top, I've got 1 minus cosine x times 1 minus cosine x. I don't know what I'm going to do with that, but I'm going to write that as 1 minus cosine x squared. And then on the bottom, I've got 1 minus cosine x times sine x. All right, and the second fraction, I got sine squared up top, sine times sine, and then I've got the same denominator, 1 minus cosine x times sine x. All right, so they have the same denominator, which means that I can add the numerators together. So I've got 1 minus cosine x in parentheses squared. I feel a foil coming on. And then down at the bottom, let's see, I'm going to change the order of that. This will look easier if I write it as sine x times 1 minus cosine x. All right, again, do not panic if you have no idea where we're going with this. We're just going to keep manipulating this thing until we figure something out. All right, so I'm going to take that numerator and FOIL that out, 1 minus cosine x. I'm going to kind of do that off to the side in like a scratch work box over here. So I'm going to take 1 minus cosine x and multiply it by 1 minus cosine x. And just multiply it out like a binomial. Okay, so I'm going to multiply my first terms. If I do a FOIL, 1 times 1. Outer terms gives me 1 times negative cosine minus cosine. Inner terms, negative cosine times 1 is another cosine. And then negative cosine times negative cosine is positive cosine squared. All right, and that's going to be 1 minus, I got 2 cosine x's in there, plus cosine squared x. Okay, so I still have no idea how this is going to turn into 2 cosecant, but I did just have the number 2 pop up in my problem, so that's looking promising. All right, so I'm going to come over here. Up top, I'm going to have my blue box answer. Okay, so what I did in the blue box is what I'm going to replace this with. All right, so that's going to be 1 minus 2 cosine x plus cosine x squared, cosine squared x. And then after the blue box in the bottom left, I had sine squared. So I'm going to say plus sine squared. And then I'm going to copy that denominator. I've got sine x times 1 minus cosine x. All right, and this is good. This is good because I've got this. Actually, let's do that in a different color. This thing right here, cosine squared plus sine squared, always equal to 1. All right, so I can combine that with this one and get 2 minus 2 cosine x up top over sine x times 1 minus cosine x. All right, and I'm almost ready. I'm going to get rid of my blue box because I need a little bit more room. All right, and let's see what we've got here. I have that 1 minus cosine x, and notice that the numerator is 2 minus 2 cosine x. I can actually factor a 2 out of the top, and I'm left with 1 minus cosine x. And then on the bottom, I've got sine x times 1 minus cosine x. And then hopefully you can see it now. These 1 minus cosine x, they're going to drop out. They divide out, and I'm left with 2 over sine. 2 over sine is exactly 2 cosecant x, right? This is equal to 2 times 1 over sine, which is exactly equal to what I want it to be. My left-hand side equal to my right-hand side. And if you're thinking, there's no way that I would have thought to factor out that 2. There's no way I would have thought to FOIL out that 1 minus cosine squared. I would have never thought to add those fractions together. Well, neither would I until my trigonometry teacher showed it to me. So I'm kind of showing you some techniques that tend to work when you're verifying identities. So now you can just kind of add those to your toolbox and say, maybe I can try that trick that she tried on that one and it'll work for me. All right, last one that I'm going to do for you. I've got thetas in here. Tangent squared minus cotangent squared is equal to secant squared minus cosecant squared. All right, neither one of these is more complicated than the other. Pick your favorite. I don't know. Let's pick the right-hand side because I haven't done anything with the right-hand side yet today. So I'm going to recopy my right-hand side. Secant squared theta minus cosecant squared theta. And again, we're leaving that left-hand side up there as an inspiration. All right, so we want to turn our secants and cosecants into tangents and cotangents, and they're all squared. And we did have a couple of identities on the identity handout that had tangents and cotangents and secants and cosecants squared. So if you want to pull that out and look at it, you can. The tangent one, you had tangent squared x, I think I used on the handout. It doesn't matter if it's x or theta. The tangent squared plus 1 was equal to secant squared. And that 1 plus cotangent x squared is equal to cosecant squared. All right, so we have kind of our identities box here. All right, so I can replace secant and cosecant with their identities. Okay, so I can replace secant with tangent squared plus 1, and I'm going to do tangent squared theta plus 1 because I've got theta. So tangent squared theta plus 1. And then I've got subtraction, and I'm going to replace cosecant squared with its identity. So we're going to have 1 plus cotangent squared. And just got to be careful. We're subtracting that whole blue bracket, so I'm going to have to subtract the whole thing. I'm going to distribute that negative sign. All right, so let's see what happens when I do that distribution. I've got tangent squared plus 1. Distribute that negative sign, and I've got minus 1 minus cotangent squared. This one was much easier than the last one, right? Because our negative ones drop out, and we have exactly what we wanted, right? Tangent squared minus cotangent squared. All right, and that is our left-hand side. And again, I'm not necessarily looking for the right answer. I'm looking for that right explanation that starts off with one side and ends up with the other side. All right, so there's some techniques that you can use. These are kind of hard to get at first until you kind of get your brain wrapped around what we're doing. A lot of practice is what really makes this get better and easier.